Hi children, hello, welcome to your home school. This is your class 10 mathematics NCERT or CBSE board. We are in our fourth chapter circles, exercise 4.2 and your problem number 9. In figure, you can see the figure here, xy and x dash y dash. Where is xy? Xy, x dash y dash are parallel tangents. Say these two tangents are parallel. Are two parallel tangents to a circle with center O. Again, understand the line here. Given xy and x dash y dash are the two tangents. The two tangents are parallel to a circle with center O. And another tangent AB. Where is another tangent AB? Yes, here it is with point of contact C intersecting XY at A. This tangent is intersecting XY tangent at A and X dash Y dash tangent at B. Prove that angle AOB is equal to 90 degree. AOB means I need to prove this angle is 90. How can I prove this? Okay, so first let us understand what is given. Given XY and x dash y dash are parallel tangents to a circle with center O. Next point, what do you know? AB is a tangent. AB is a tangent with point of contact C to a circle touches or intersects, you can write, intersects xy and x dash y dash tangents at A and B. Right? Now I am going to do a construction here. Construction. What is the construction we do here? Join OC. Yes. Next, to prove. What we need to prove here? Angle AOB is equal to 90 degree. So these are all the given data in the problem. Let us start our proof. How can we start our proof? Before writing here, just see the figure once carefully. Tangents drawn from an external point to a circle. Just see only A point. You can see two tangents emerging from A point. AP, AC are the tangents. If I take those two are the tangents, then A becomes the external point. You can remember a statement. Tangents drawn from an external point to a circle are equal. According to that statement, I can say AP is equal to AC. Right? Then if I consider these two triangles now, children, look here carefully. AP is equal to AC. AO is equal to AO. It is a common side for the two triangles. And what is OP and OC? OP and OC are the radius of a same circle. Then these two sides are also equal. Therefore, by SSS similarity criteria, side criteria, I can say that the two triangles are congruent. If they are congruent, what I can say? By CPCT, remaining angles it might be or remaining sides you can equate. Already all the sides are equal. Let us equate the angles. This angle equal to this angle, I prove. With this, I am going to start my proof. Okay. So once again, I repeat here, how can we solve this problem? Consider these two triangles, make them congruent. After making them congruent, equate these two angles. Okay, similarly, these two angles will be equal. Then afterwards, you remember that a transversal, the interior angles of a transversal on the same side are supplementary. Right? If they are supplementary, what you can say? This angle plus this angle is equal to 180 degree. If this is 180, then I will add this angle, this plus this equal to 180, and I find these two angles. After getting these two, the interior angles of a triangle sum is 180 degrees. Then automatically we get here 90. How can we prove this problem? So just a small tiny hint I am going to give you. Have a look here. These two are tangents and this is also a tangent. I will consider A and B are the external points. If A is an external point, the tangents drawn from an external point are equal. According to that statement, I say that AP is equal to AC and AO is equal to AO. If I take these two triangles, I can compare like this. AP equal to AC, AO equal to AO. Why? AO is a common side. OP equal to OC. What is OP and OC? OP and OC are the radius of a same circle. Then I can say that by SSS criteria, I can say these two triangles are congruent. If they are congruent, by CPCT, I can equate the remaining parts. I will equate this angle equal to this angle. Similarly, when I compare these two triangles and I can equate these two angles. Now, second step I am saying here, the sum of the interior angles of a same side of a transversal is equal to 180 degrees. Now, this angle plus this angle is equal to 180. Then, you add up and you are going to get this interior angles of this triangle you are going to get. After getting these two, your third step is consider this triangle. Okay, you got these two angles now. Consider this triangle and apply that interior angles of a triangle sum is 180 degrees. With the last statement, we can prove that this angle is equal to 90 degrees. Okay, children, let us start. This is only the hint. Let's start your problem. How can we start? Proof. Consider triangle OPA and OCA. Triangle OCA. I know that tangents drawn from an external point. Tangents drawn from an external point are equal. According to that, I can say that AP is equal to AC. OPA, AP equal to AC. And AO is equal to AO. This tangents, how I can say equal? Given. And how I can say AO equal to AO? Common. One more. OP is equal to OC. Radius of a same circle. Radius of same circle are equal. Therefore, triangle OPA is congruent to triangle OCA. By which criteria? SSS criteria. Okay. Now next line, what you can consider here? By CPCT. By CPCT, corresponding parts of a congruent triangles, I can equate other angles. What are the angles I need to equate here? Angle PAO is equal to angle CAO. Angle PAO is equal to angle CAO equal. Next step, if they are equal, what is this complete angle? Angle PAC. How can I write this PAC angle? Angle PAO plus CAO. Observe carefully here. I know that this is equal to this. Now I am going to consider this angle. You can see the angle. What is this angle? Angle PAO plus angle CAO. And now finally I consider this triangle. So I try to make this angle also equal to this angle. So therefore instead of PAO, I will write it as CAO. CAO plus CAO is equal to 2 times angle CAO. What is this, children? Angle PAC is equal to 2 times CAO. Similarly, when I consider these two triangles, I can say that angle OBC is equal to angle OBQ. Finally, angle QBC. Now say, children, angle QBC is equal to this plus this angle. This angle equal to this you equate. Then you are going to get that 2 times angle OBC. Understand the concept carefully. Angle PAC is nothing but 2 times angle CAO. And what is angle QBC? It is 2 times angle OBC. Mark this as 1 and 2. Second step starts here. What is your second step? Sum of interior angles of same side of a transversal is, you can write supplementary also, is 180 degrees. Now add these two, children. Interior angles means angle PAC plus angle QBC. Angle PAC plus angle QBC is equal to 180 degrees. By the way, what is angle PAC from equation 1? You can write it as 2 times angle CAO plus QBC. 2 times angle OBC is equal to 180 degrees. Now take out 2 common. Angle CAO plus angle OBC is equal to 180 degrees. Cancel this to 90 degrees. Therefore, angle CAO plus angle OBC is equal to 90 degrees. Mark this third equation. See here, up to here, first set is completed. Then second part of the problem is completed. Now third part, what is that? We know sum of interior angles of a triangle. Sum of interior angles of a triangle is 180 degrees. Yes, do you know everybody? Yes. Consider the triangle. In triangle OBA, angle AOB plus angle OBC or OBA also you can write. We got here OBC, right? OBC or OBA both are same, plus angle CAO is equal to 180 degrees. But I know that angle OBC plus CAO. OBC plus CAO. This angle plus this angle is 90. Substitute that. 90 degree is equal to 180. Now send this 90 other side. Angle AOB is equal to 180 degree minus 90 degree. Therefore, angle AOB is equal to, subtract that, you are going to get 90 degrees. What we need to prove in this figure? Prove that angle AOB is equal to 90 degrees. This is the thing we need to prove. Therefore, final answer. Hence, it is proved. Understand the problem here. There is nothing there in the problem. If these two are the tangents, then I consider these two are the external points. Tangents drawn from an external point are equal. According to that rule, I have taken these two triangles and compared, made them congruent. If they are congruent, by CPCT, I equated these two angles. When I consider this angle, any one angle I skip, children. This angle I don't want. Final, I need to consider this triangle, right? So I equate in this form only. That means angle PAC is equal to 2 times angle CAO. Means I need to convert in this triangle angle. So similarly, this angle also. What is that? Angle QBC is equal to 2 times angle OBC. Finally, when you consider this triangle, second step, sum of the interior angles of a transversal of one side, sum will be 180. This plus this equal to 180. Then you substitute these two, you are going to get this angle plus this angle will be 90. Then third step, we know that sum of the interior angles of a triangle is 180. These two sum is 90. Then what will be this? 180 minus 90 will be 90. That is the thing we need to prove. 10th problem. Prove that the angle between the two tangents drawn from an external point to a circle is supplementary to the angle subtended by the line segment joining the point of contact at the center. So, they did not give us any figure. We need to draw the figure. Put an external point and draw two tangents to a circle, right? So what is the question they asked? Prove that the angles between the two tangents means this is the angle, right? The angle between the two tangents drawn from an external point to a circle is supplementary to the angle subtended by the line segment joining the point of contact to the center. Where are the line segment joining the point of contact to the center? This is the line, right? Means it is a radius. The angle means this angle plus this angle is supplementary. Supplementary means this angle plus this angle sum is equal to 180 degrees. I need to prove. How can I prove this one? So, first understand the problem carefully. When a tangents are arise from a same external point, tangents drawn from an external point, the length of the tangents are equal. If they are equal, this and this is equal. Now I am going to join P to O. Then it becomes a common line, common side. Then this side is also equal. Radius of a same circle are equal. By SSS criteria, I say that the two triangles are congruent. They are congruent. If they are congruent by CPCT, I am going to equate their angles. Here, this angle equal to this and this angle equal to this. Now, I am going to consider any one triangle, children. Then this angle plus this angle plus this angle is equal to 180. I know this will be perpendicular 90. Then remaining two angles sum will be 90 degrees. By taking that into consideration, I am going to prove this. Let's start our proof. Given solution data. Given P is an external point to a circle with center O. PQ and PR are the tangents such that PQ is equal to PR. Tangents drawn from the same external point to a circle are equal. Construction. What is the construction I have done here? Join PO. Next, what to prove? To prove angle QPR is equal to angle QPR plus angle QOR is equal to 180 degrees. Anyone you can say, children, angle QOR is equal to 180 minus QPR also, they may ask the question. Or angle QPR is equal to 180 minus angle QOR. Prove means same problem. They may ask in 3 ways. Proof. How do we start our proof here? Consider the triangle. Which triangle we are going to consider? Consider PQO triangle and PRO triangle. We know that PQ is equal to PR. How, children? Tangents drawn from an external point are equal. According to that statement, I say this. Given tangents drawn from an external point segment, therefore it is given, I will say. PO is equal to PO. How? It is a common side for both the triangles. Then next, QO is equal to RO. Radius drawn from the same center of a circle are equal. Therefore, triangle PQO is congruent to triangle PRO. If these two triangles are equal, by CPCT, corresponding parts of a congruent triangles, I am going to equate this angle equal to this angle. By CPCT, I say that angle QPO is equal to angle OPR. Angle OPR and angle QOP is equal to ROP. See here, by CPCT, this angle equal to this angle and this angle equal to this angle I have equated. Okay. Now, what we are going to do? Let me consider the triangle. Any one triangle you can take. Consider any one triangle, children. Your wish. You may take either this or this. Consider triangle PQO if I say. What is the interior angles of a triangle? It will be 180 degrees as we know already. Right? So, I take this angle. That is angle QPO plus angle QOP plus angle PQO is equal to 180 degrees. We know that interior angle sum of a triangle is 180. Angle QPO is how much? OPR. And angle QOP is equal to ROP. But I don't substitute that. I just substitute only this 90. What is that? Angle QPO plus angle QOP plus PQO, tangent arise from an external point, is always perpendicular to the radius of a circle. This will be 90 degree. Then this 90 degrees send other side. Angle QPO plus angle QOP is equal to 180 degrees. This 90, if it comes this side, minus. 180 minus 90 will be 90 degree. So, what did we get here, children? Angle QPO plus angle QOP is equal to 90 degrees. Look here, this angle plus this angle equal to 90. Now, I'm going to multiply 2 on both sides. Just see what happens here. Multiply 2 on both sides. Multiply 2 on both sides. That means 2 times angle QPO plus 2 times angle QOP is equal to 92 180 degrees. What is 2 angle QPO? You know that angle QPO is equal to OPR, right? 2 times angle QPO is nothing but, I may write here one more point, children. Look here. If I talk about complete angle QPR, I may say that QPO plus OPR, right? Instead of OPR, I substitute QPO according to this statement. So what happens? Angle QPR is equal to 2 times angle QPO. Similarly, I may write it as angle QOR is equal to 2 times angle QOP. QOP is equal to ROP. Then angle QOR is equal to QOP plus ROP. Therefore, I can say that angle QOR is equal to 2 times angle QOP. So now, what is 2 times angle QPO? It is QPR. And what is 2 times angle QOP? It is QOR is equal to 180 degrees. Now observe carefully, children. Angle QPR, this angle, plus angle QOR, this angle, both sum is equal to 180 degrees. Therefore, they are supplementary. Final statement. Therefore, hence, it is proved. This is the thing we need to prove. Understand here. Once again, I repeat the problem. These are all not so easy. Little confusion will be there. But once you practice, these are all will be very easy for you. Observe here carefully. Tangents drawn from an external point to a circle with center O. Tangents will be equal and they are perpendicular. So according to that, I can say that tangent length equal. If I consider these two triangles, this side equal to this side and this is a common side and these two are the radius. These two triangles are congruent. If they are congruent by corresponding parts of a congruent triangle, what did I say? This angle equal to this angle and this angle equal to this angle. Right? So when I equate this equal to this, what is complete angle? I can say that 2 times of this angle or 2 times of this angle. Any angle you can say. Now this one also. This angle equal to this angle. Then when this full angle, if I talk 2 times this angle or 2 times this angle, you can say. I have taken this triangle. Sum of the interior angle of this triangle is 180. This angle we know it is 90. Then this plus this is equal to 90 degrees you get. Now you just think what I do, I get the answer. Multiply 2 on both sides. 2 times angle QPO, 2 times angle QOP is equal to 180. What is 2 times this one? It is QPR and this is QOR. Sum is supplementary. 11th problem. Prove that parallelogram circumscribing a circle is a rhombus. See here children, similar type of problem we have done. Before we have done a quadrilateral circumscribing a circle. Same manner we prove, but only 2 lines you have a change with that problem. What is that 2 lines? This is a parallelogram. What do you remember? Opposite sides are parallel and they are equal. Only with that point we are going to change the problem here. Let's see. Look here. ABCD is a parallelogram. Solution. We start our proof here. Data given ABCD is a parallelogram. ABCD is a parallelogram and circumscribing a circle, and you can see a circle, right? Parallelogram. Circumscribing a circle with center O. Circumscribing a circle with center O. What you need to prove? To prove that ABCD is a rhombus. What is the technique, children? If you need to prove rhombus, the corresponding sides are equal. If you are able to prove, then it becomes a rhombus. How can I prove now? Let me consider A. What is A? A is an external point. B external point, C external point, D is also external point. Now let's start our proof. We know that ABCD is a parallelogram and it is circumscribing a circle with center O. If A is an external point, then what you can say, children? If no need, no, what we can write? Let's start with our proof, children. A is an external point. Then what we remember the statement? Tangents drawn from an external point. Tangents drawn from an external point are equal. Tangents drawn from an external point are equal. According to this statement, what I can say? AP is equal to AS. Same statement continue for all the points, children. Next one. If B is an external point, tangents drawn from an external point are equal. So and so I am writing here. Same statement you write. If B is external point, what are the tangents, children? BP equal to BQ. See here on left hand side, try to write only this side and this side. Right? Then if C is an external point, what you can say? CR is equal to CQ. And if D is an external point, you can say DR is equal to DS. Mark all these as 1, 2, 3 and 4 equations. AP equal to AS, BP equal to BQ, CR equal to CQ, DR equal to DS. Okay. Now what's your next step? Let's add all the equation. Adding equation 1, 2, 3 and 4. How we are going to add? Left hand side, right hand side, you add. That will be AP plus BP is equal to, AP plus BP plus CR plus DR is equal to AS plus BQ plus CQ plus DS. Now you remember, children, what is AP plus PB? AB. And CR plus DR? DC you can write, or CD you can write. Then coming to here, AS and DS. AS plus DS is AD. BQ plus CQ is BC. Right? Let's write here. AP plus BP is equal to AP and CR plus DR equal to CD. That equal to AS plus DS. It will be AD plus BC. Right? AB plus CD is equal to BC plus AD we got. But now I am going to change. Before problem, they asked us to prove only this much. We have ended up in that problem. Do you remember? Now in this problem, we need to do further. What is that? We need to do this Parallelogram, we need to prove it as a rhombus. That means I know that in a parallelogram, opposite, we know this, right? Opposite sides are parallel and they are equal. If they are equal, what are equal, children? AB is equal to CD and BC is equal to DA or AD. Now substitute this anywhere, CD equal to AB or AB equal to CD, any one you can equate. Now AB plus this point you just remember, AB plus instead of CD I am writing again AB is equal to, instead of AD I will substitute BC. BC plus BC. Now it will be AB plus AB will be 2AB. BC plus BC will be 2BC. 2 cancel. AB equal to BC. Now look here, children, what we have proved, AB is equal to BC. Similarly, I can prove all sides are equal. That is, AB equal to BC is equal to CD is equal to DA. Now what I was able to say, all these sides are equal. Therefore, ABCD is a rhombus. Right? This is the thing we need to prove. So last statement we need to know, what is that? Hence, they asked us to prove. We proved it. Hence, it is proved. With this, we are going to end our session today. In our next session, we are going to end this chapter. Until that, keep watching. Thank you all.